Hello, welcome to this video of introduction section about linear algebra. So firstly, let me introduce my name. My name is Hendrik. I'm a student of Nusa University. Now I'm majoring in Informatics Engineering Study Program. I will talk about two main topics in this introduction video, which is what is linear algebra, and second is what is the relationship between linear algebra and Informatics Study Program. The explanation. Let's move to explanation. Linear algebra, also known as algebra linear in Bahasa Indonesia, is a branch of mathematics that studies several fundamental concepts. The first is lines and planes. Linear algebra explores the properties of lines and planes in space. The second is vector space. It deals into the concept of vector space, which involve vector and operation that can be performed on them. And the third is linear transformation. Linear algebra provides tools to understand linear system of equation and matrix. Linear equation involve variable in linear form, and this will help identify solution to such system. So, in general, linear algebra is composed of three essential elements. The first is variable. Variable represented by the alphabet such as x, y, z, and many more. You can use whatever alphabet that you want. The variable serves to represent the changing or variable value. The second is coefficient. Coefficient, these are values multiplied by variables. And the third is constant. Constant is fixed value within the algebraic expression. Example is 8xy plus 2z plus 3. In here expression, we know that the variable is x, y, and z. Then the coefficient is 8, which is the coefficient of variable x and y. Then 2 is the coefficient of variable z. Then the constant here is 3. After we talk about what is linear algebra and its expression, then we talk about why it's important to learn the linear algebra, especially for Informatics Study Program students. Linear algebra has a broad application including technology, computer graphics, and machine learning in the world of technology and informatics. Linear algebra is highly relevant and essential. Here are several examples how linear algebra is applied in computing. The first is computer graphics. If you know 3D rendering in computer graphics software, use transformation matrix to project 3D objects onto 2D screens like display on your laptop, also in your iPad or in your phone. Matrix operations are used to manipulate object positions, rotation, and scales. Shadow programming. Shadow in computer graphics is matrix to calculate lighting, shadows, and other visual effects. For instance, the 3D polygonal structure of game characters and background, as well as other 3D graphics applications, utilize matrix operation. Digital image processing. Digital images are represented as matrix, where each pixel has a numerical value corresponding to its color. Linear operations such as matrix addition, subtraction, and multiplication are used in image drawing and processing. The real example of this application is in image filter. Linear algebra is applied in image filters such as edge detection, blurring, and sharpening. Then we have image compression too. Linear transformation are used in image compression methods like Fourier transform and discrete Gaussian transform. The third field of application is audio and music processing. So here the Fourier transform. In sound and music frequency analysis, Fourier transform convert time domain signal into frequency domains. Then audio processing. Linear algebra is used in audio processing for text like noise reduction, equalization, and sound effects. So the fourth field of application is information security or cybersecurity. Information security involves mathematics, including linear algebra. Cybersecurity systems perform calculation during the penetration testing to outwit hackers or compile data reports for threat identification. So the real-life application is encryption. Encryption algorithms like RSA and AES utilize matrix operation. Then we have anomaly detection. Data analysis using linear algebra detects anomalies in network traffic. The field of application is optimization and data analysis. Linear algebra is employed in linear programming to optimize solutions to problems with specific constraints. An example is the simplex optimization method used in linear programming. The sixth field of application is data processing and machine learning. Linear algebra is used in data analysis, linear regression, and statistical processing in data analysis. Methods like principal component analysis or PCA in short and linear regression leverage linear algebra concept is used in machine learning. The seventh is physics simulation and gaming. Physics simulation in games or any simulation, linear algebra is used to calculate object movement, collision, and force. The last is biomedical signal processing. Electrocardiograms or EKG and electroencephalograms or EEG involve signal processing for medical, diagnostic, and monitoring. Understanding linear algebra and its application is crucial for researchers and practitioners in this field, especially in Informatics study program. A solid foundation in linear algebra and optimization theory is essential for making significant contribution to machine learning, robotics, and computer vision. Mastery of this concept enables us to understand and address various problems more effectively. So I think there's a lot that I've been talk about linear algebra, and sorry for many mistakes that I made, and thank you for watching. See you.